everyone. My name is Tony Riggs. I'm an applications engineer here at GoEngineer. Um, we always are trying to find more interesting and fun things to print with a 3D printer. And to be honest, the 3D printed guitar has been on our list of things to do for quite some time. Um, Zach Richter, kind of inspired, some of this, and he was a force behind it. Um, but we've had help from multiple other people, multiple other offices to get this going, and we'll kind of tell the story of how things started with the guitar and go from there. Um, so I kind of broke this up into three different sections. Scanning the guitar and figuring out how we wanted to really get the data for the guitar, working on the SOLIDWORKS model, making it more printable, and then the finished version, putting everything together and some of the assembly work that we did. We started this off, went out to Guitar Center and purchased a Epiphone Les Paul and brought it back to the office, and we actually didn't even plug it in and try to play it before we started tearing it apart. And got out the caliper and tried to take some measurements. And we started working on just modeling the guitar in SolidWorks. Um, and I think we've got a pretty good model of it, done by hand. Uh, but the scanner department manager happened to be in town one day with a laser scanner and said, "Hey, why don't we scan it?" So we said, "Yeah, sure, let's do that." Um, we also found a little bit of information on the guitar itself off the web, so we'll take a look at that a little bit. So we went out and just, I think we paid $180 for this used Epiphone Les Paul. I was I was talking about this with my sister-in-law, and she thought we'd actually took a real Les Paul um, apart, and said no, it's just an Epiphone. Um, but we were measuring on it and trying to figure out how we would want to print the guitar, looking at how the actual guitar was manufactured, and that gave us some ideas. Found a wiring diagram and some general dimensions that we wanted to go off of. Um, and I tried to download a couple different versions off the web, from GrabCAD or wherever, and I was really surprised at the differences and how far some of them were off from the actual model. So we were really glad when the scanning option popped up. We used a HandyScan 700. It was a very easy to use tool, portable metrology. Looks like I got Metrod. I can't spell apparently. Metrology grade, very user friendly. And then we converted that over into a SOLIDWORKS model. We were able to bring in 2D sketches from the scan data as well as 3D surfaces. And we'll show some of that here in just a little bit. But we've got the kind of the scan um, information here. We're showing this in DesignX. We've actually got some of the scans and the sketches and the surface kind of shown there. And it's a real nice tool to be able to take those entities right from the scan and really export those into SOLIDWORKS and use those to develop our regular CAD model. It's a very nice way of doing things. Here we've got the screenshot from SOLIDWORKS actually showing some of the extrusions and cuts. So where it shows the sketch 1 mesh 13, that's actually coming from the scan data. Then the mesh fit down below that is the curved surface that I show on top there. coming from the scan. And I actually have a quick little video of Cameron going through and scanning the guitar here in my office the first time. Uh, so it's a HandyScan 700 from Amatec. You can actually see the lasers going through and collecting the data on the guitar. We've got the locating dots there that help register everything and keep everything lined up together. It definitely makes it where you can take the guitar, pick it up, and scan the backside at the same time. It was kind of funny that the fret markers on the neck actually started picking up some as markers on the scan. So this is a pretty quick little scan showing some of the basic operations, and you flip things over and check to see how much data on the scan is getting collected. Let's let that go for a couple more seconds there. Okay. So then working on the SOLIDWORKS model, planning on how to print the body and the neck. We were looking at the actual body, and there's additional holes in the body to help hold things together while they're getting painted. Some extra holes that have to be a certain way because that's the only way to get the access for the drill bit to cut the holes between the different pockets. But since we were going to be 3D printing this, we knew we could definitely take some creative freedom to print the guitar a little bit differently. The body of the guitar, we were trying to come up with a similar weight and feel to the actual guitar. We also wanted it fairly strong down the center section. We had a lot of things that were also mounting to the guitar in that center section. So we left the middle, say 6 or 7 inches, down through the middle of the guitar, printed solid. And then with a sparse interior, we used that on the wing sections. When we printed the guitar, we actually printed it on its side, not laying flat in the build tray. We wanted a nice smooth surface finish on the face of the guitar. Get rid of as much stepping as we could on the exposed surfaces. We put some reinforced areas in there for inserts. For most of the inserts, I took some brass knurled inserts and used a soldering iron to press them into the plastic. It melts down into the plastic very nicely, gives a nice mechanical thread. For most of the holes, we did not print them in the actual model. Laid the pickups and different things on the guitar and kind of transferred the holes down into the body after the part was printed. There were a couple passages between the pockets that we did a little bit differently because we could, like I said, because it was getting printed. For the neck, we actually printed it on its side with the fretboard, facing out to give that, the best surface finish. We printed it all solid. We had, several people worried about how, strong the neck was going to be, because most of the real necks have a metal truss rod running down the middle of them to give them additional strength. We'll talk about that a little bit later on. Also, where the neck attaches to the body, there were just some large, what I would call self-tapping, wood screws that were attaching the original. So what I ended up doing was actually in the software for the 3D printer, you can go in and insert pauses. And we actually went in and removed the support material that was supposed to be in the cavity for the holes for where the neck attached, and we made the little cavities a little bit bigger, big enough to um, support adding some actual hardware in there, some nuts into the neck to actually bolt everything to. I think I've got some screenshots of that here in a little bit. So this is the area that I was talking about. So I've done pauses before where we've put nuts and hardware in to build as they were going, but they were typically the nuts were laying flat. These were actually inserted vertically. The image there on the right, the neck was actually printed in that vertical orientation, so that dropping the nut into the hole was a little bit different. A lot of times I like to put something on top of, say, a washer or whatever that's plastic that then gets built back on top of, as opposed to just building straight on top of the washer. So if we look here on the screen, here's the nut, where it would go in the body, but we've got this other rectangular body directly above that. I actually printed a small rectangular, plastic piece. So I made the pocket big enough to put the nut in, didn't drop the plastic piece on top of that. So when we resumed the build, it was printing on top of that plastic as opposed to trying to print right on top of the nut. So that worked out, pretty good actually. So at the top of each of those little pockets, we put a little pause in, made for a very nice mechanical attachment. For the let me go back one. For the frets, we actually came in and the scan, picked up the frets. We actually removed the frets, and in SOLIDWORKS, I went through and actually, created a cut groove where the fret wire should be, and I kind of centered it up on where the scan was finding the frets. Then we went in and actually added the fret wires manually, and I've got some pictures of that a little bit later on. Now on to the finished version. We've got a couple different levels here. Components from the original guitar, the tuning knobs up on the head, the pickups, the pick guard. Those were some of the things that we actually used from the original. And we thought about printing a colorful pick guard, but the color on it actually matched the pickups pretty good, so we kind of liked the way that it looked. We ended up replacing the wires and replacing the pots on the dials. There were a couple of different length pots that were available. The originals were kind of short, and the way that the inside of the pocket where those all mount, we left that with a nice flat bottom. On the original body of the guitar, you can see where they've gone in and maybe with a circular cutter actually cut a deeper hole because some of the dials are at different levels on the body. With the longer pots, you could actually use the double jam nuts to actually adjust the length that they stick out from the face of the guitar, and get them all nice and even for us. A couple of the other printed components that we did, we'll see some of the fret markers, some of the knobs, and some of the rear covers on the back side we did something kind of fun with. So on the finished version, we've got this is, assembled partially, before the paint job. We've got the knobs there. We actually drew this up with the GoEngineer logo on the inside, and the numbers from 0 to, we actually went all the way to 11, so we could turn it up a little bit louder, right? We've got some clear covers on the back side to actually let you see down inside see the wiring in the guitar. So the body and the neck were all printed in ASA material on a Stratasys FDM printer. We used a Fortis 400 to do the body. For the neck, it was just a little bit longer than we could fit on the 400, so we actually used a 900 to take advantage of the 3 foot by 2 foot by 3 foot build volume that was there. For the clear parts and the knob, we ended up using the a couple different machines. We used the Connex 350, and some of them we printed on the new J750 to get the nice clear covers where you could see down inside everything. And there's a picture of the neck as it came right off the printer. There's a little bit of fasting because of the orientation on, say, the bottom of the neck and around the end of the guitar. Those are all actually hand finished and sanded and smoothed down and then painted up a little bit. For the fret wire, I went through and laid those out individually and cut them one at a time out of pieces of fret wire, trimming those up. And then we went in and filed each one of those down where they were nice and rounded on the end, smoothed everything off. To actually get the parts in, we used an arbor press. So there's a kind of a picture of the neck inside the press. And what I did, I actually printed a matching piece for the top and the bottom to hold the neck. I didn't want the hard metal piece to mar up the underside or top side of the guitar neck. So we used that to press each of the fret wires down inside there. We were toying with what to do with the neck, whether to leave it the natural light gray ASA color. We kind of left it up to the painter to decide. He ended up, going ahead and masking off each of the fret wires individually and painting the fretboard there a black color to match the rest of the neck. And I think it turned out, pretty good the way it ended up. So here's a kind of a full view of the guitar, again before paint. And then we've got the kind of the finished version there with some of the pieces in. I don't have the fret markers or the wires installed quite yet. We'll get to that here in a second. Nice shiny head there with the tuning pegs. It's amazing how black can pick up fingerprints pretty easily. And we came in we had a couple different versions of the fret markers. We actually took the GoEngineer logo and in the light green, surrounded by the white, and we actually, used a little super glue and pressed those into the printed holes after everything was painted up. So there's a picture of the guitar in the guitar case, ready to go. We actually took this out to a company meeting in the Salt Lake area and ended up giving it to the CEO of GoEngineer, have him hang it up on his wall for a little decoration. Have a little fun with it. So we had a couple of the guys play the guitar while we were out there at our meetings. We'll see a video of it playing here in a little bit, and there's a picture of Brad with the guitar as well. So back to the guitar neck, we had people concerned about the strength of the neck. The neck is a little bit weak, and when we print our next one, and we probably will, we'll probably end up putting in some sort of truss rod, whether it be a round rod, I-beam, or T-section, something to give it a little bit more strength. The guitar was able to tune, pretty decently. If you tuned it too tight, the neck would start to bend a little bit, and you can get a little bit of distance off of the fret. As you're playing it as well, as you can actually bend the neck, and it kind of had a built-in, I guess, whammy bar, if you want to talk about it that way. So we're definitely going to do some, maybe a version 2, wrap in some stress analysis on the guitar neck and see what kind of structural piece we can add into the neck on the next one. We went out and did all kinds of searches. If you type in, crazy guitar version or whatever on Google, it's amazing some of the pictures of the different guitars that people have out there. There's been, printed guitars before, and there will probably continue to be more and more printed guitars. Whether we end up doing an acoustic guitar, that's kind of a challenge that we may play with. I currently have a violin in my office that may end up being the next project or a project down the line. This was definitely a pretty fun project to work on. I think we kind of started on this project actually last year about this time, maybe October, November time frame. Some time for the scanning and the CAD modeling, a little bit of time for the printing and assembling and painting. But overall, it was a pretty fun little project. See if we can click on the link here and get some of the videos to play.
He's been playing since he was
So we also went out and bought this, very small little Marshall amplifier. So that's where all that sound was coming through. So that's one kind of style of play. Zach's got a little bit different style. On both the videos, you can see, when they're done, the smile on their face. They're actually having quite a bit of fun, playing the guitar. But maybe they have that much fun playing any guitar. You never know. It was definitely a fun little project to work on. We'll see what we get to next. The last slide here, GoEngineer provides design and manufacturing tools with expertise that enables customers to reduce cost, risk, time required to go live with new technologies, and ultimately new product introductions. That's something that we preach, but we practice it as well. A lot of the people that we have here have spent time. That sounds kind of bad. Spent time in industry. So we've got practical experience. Some of us miss design projects here and there. So this is a great opportunity for us to get our design skills going again, and just have fun with the projects. So again, my name is Tony Riggs with GoEngineer. Down on the bottom left, you can see my email address if you've got any questions, triggs@goengineer.com. We've got a whole library of videos out on our YouTube page, also out on our website as well. So watch for this webinar if you want to watch it again. We'll have it posted out there here in a little bit, and hope this was an interesting and inspiring webinar. I'll leave it open for a little bit to see if anybody has any questions. Well, I don't see any questions popping up quite yet. So again, if you have anything, shoot me an email. And as always, have fun and have fun with your designs. So thanks for connecting with the webinar, and we'll talk to you guys later.